The sheer number of powerful tornadoes this year and the misery they caused have dominated weather news the last few months. Here I'd like to mention a few stories related to the record-breaking tornado year which haven't been given a lot of attention. First is the notion that big cities don't get hit by tornadoes, that downtown areas are somehow protected. Truth is, just in the last 5 years, tornadoes have barreled through parts of Atlanta, Fort Worth, and New York City, just to name a few. Having said that, it is unusual for a tornado to strike a city, but only because downtowns cover very little land area relative to the entire nation, and thus are small targets. But over time, urban sprawl has gradually increased the size of these metropolitan targets. For example, when you read through the descriptions of the destruction from the Joplin and Tuscaloosa tornadoes, you find that many of the homes or neighborhoods were just a few years old. Next, I'd like to talk about assessing tornado damage. An instrument called ASTER aboard a NASA satellite helped in this process for the Alabama tornadoes, the first time it was used for a major tornado outbreak. ASTER stands for Advanced Spaceborne Thermal Emission and Reflection Radiometer. In English, that means it combines visible and infrared wavelengths to produce hybrid images that show details that the visible and infrared don't show alone. Now here's an example taken a few days after the late April tornado outbreak. You're looking at a 12 by 16 mile area of northern Alabama, so about 200 square miles, with the eastern side of Tuscaloosa visible there on the bottom left. Now in this false color image, pink is vegetation, while aqua represents its absence. The skinny aqua line across the bottom is Interstate 20, while the somewhat wider, winding zone of aqua to the north is a river. Now the tornado that went through this area scoured the surface, and the tearing up of all that vegetation makes its track stand out as this swath of aqua that stretches from southwest to northeast across the image. The satellite perspective really helped survey teams get a full and accurate picture of the tornado path, particularly in remote areas. My last comment involves the direct measurement of wind speed in and around tornadoes. Such measurements are pretty rare. It's just not that common for a tornado to pass over an anemometer. But it happened on May 24th in Oklahoma, a state that, at least compared to other states, has a dense network of high-quality weather-observing equipment, with at least one site in each county. The measurement was taken near El Reno, about 20 miles west of Oklahoma City, where an anemometer recorded a maximum wind gust of 151 miles per hour with a 1-minute average wind speed of 115 miles per hour. Some of the instrumentation at that site was destroyed by the tornado, which was on the ground for 65 miles and rated EF5, with estimated peak winds in excess of 210 miles per hour. Now, the pace of tornadoes has slowed this month and should continue to do so into July, as the contrast in air masses needed to generate strong thunderstorms continues to lessen in summer. Paul Knight will let us know if there are any severe weather threats in the extended forecast coming up next.